Study of coupling agent on the properties of talc modified calcium carbonate / tamarind seed composites. Abstract in our study is to enhance the mechanical properties in hybrid composite laminates. The composite laminates will be prepared by calcium carbonate / tamarind seed. Talc was mixed in proportions on single screw extruder to obtain the plastic granules of uniform size and composition. These granules were processed on compression molding machine, semi-automatic hydraulic press, at required temperature and pressure to obtain the composite sheet of size 155 x 155 mm. Specimens of required size and shape were cut from the sheet for analysis of various mechanical, thermal, and chemical properties. Keywords: calcium carbonate and tamarind seed, talc, mechanical properties. 1. Introduction. Composite materials play an important role in engineering. In that thermoset plastic materials are widely used in various engineering industries because of their superior performance and biodegradable properties. Though coupling agents are widely used in the fields, polymers for highly biodegradable. The ethylene propylene grafted with maleic anhydride are the most commonly used thermoset plastic in polymer matrix composites have a good mechanical properties. 1. It explore that the use of DPMI as a coupling agent for the composites of wheat straw / polyethylene, PE, increased its modulus properties significantly. 2. Maleilated polyolefins such as MPE and polypropylene, MPP, were found efficient compatibilizers for improving mechanical properties of PE and PP filled with wood fibers. In our work upon all of these papers we concluded that DPMI have high in mechanical properties. So our studies are based on coupling agents. 2. Materials and method. 2.1 Coupling agents. A coupling agent is defined as a compound which provides a chemical bond between two dissimilar materials, usually an inorganic and an organic. The inorganic compatibility derives from alkali groups attached to the silicon atom. The coupling material was ethylene propylene grafted with maleic anhydride, EPG-MA, Exciler VA 1803, with a glass transition temperature Tg of -57 oC. Figure 1. Propylene grafted with maleic anhydride. EPM is considered a valuable elastomer due to its useful chemical and physical properties. It is resistant to heat, oxidation, ozone and the weather. 2.2 Calcium carbonate. The molecular formula of calcium carbonate is CaCO3. It is extracted from rock as a minerals calcite and aragonite. It is mainly in the form of shells of marine organism. The shell-type calcium carbonate is reduced into fine granules with the help of crushing, grinding, precipitation and classifying high-purity white like talc for research purpose process. It is medicinally used as a calcium supplement or as an antacid, but excessive consumption can be hazardous. Calcium carbonate will react with water that is saturated with carbon dioxide to form the soluble calcium bicarbonate. CaCO3, S, plus CO2, G, plus H2O, L. Ca, HCO3, 2, AQ. This reaction is important in the erosion of carbonate rock, forming caverns, and leads to hard water in many regions. An unusual form of calcium carbonate is the hexahydrate, IJERT, CaCO3 6H2O. IJERT is stable only below 8 degrees Celsius. The thermodynamically stable form of CaCO3 under normal conditions is hexagonal SS CaCO3, the mineral calcite. Other forms can be prepared, the denser, 2.83G/cm3, orthorhombic. CaCO3, the mineral aragonite, and CaCO3, occurring as the mineral vaterite. The aragonite form can be prepared by precipitation at temperatures above 85 degrees Celsius, the vaterite form can be prepared by precipitation at 60 degrees Celsius. Calcite contains calcium atoms coordinated by 6 oxygen atoms, in aragonite they are coordinated by 9 oxygen atoms. The vaterite structure is not fully understood. Magnesium carbonate, MgCO3, has the calcite structure, whereas strontium carbonate and barium carbonate, SrCO3 and BaCO3, adopt the aragonite structure, reflecting their larger ionic radii. 2.3 Tamarind seed. Tamarind is the fruit of Tamarindus indica popularly used in Indian cuisine. Roasted tamarind seeds are a popular snack amongst the rural population. Tamarind seeds are shiny black in color and have numerous nutritional and health benefits. If the talc type tamarind seed is prepared by using the following process: soaked, tan seed, dry in sunlight, powder, pulverize machine. The excellent gelling cum adhesive characteristics of the decorticated seed powder can lead to several applications in the field of engineering. Figure 3 Talc tamarind seed. 3 Methodology. Compression molding machine was made on and required temperature was allowed to attain. Mold halves were cleaned and release agent, silicon, was applied on the mold surfaces. Plastic granules were kept in mold halves and mold was clamped in semi-automatic compression molding machine. Semi-automatic hydraulic press used for making the composites is shown in figure 4. Different sets of experiments were conducted to get the sheet of minimum defects by varying the process parameters such as temperature and pressure. Following were the optimized conditions for getting good quality sheet of calcium carbonate polypropylene composite. Processing temperature, 200 degrees C. Clamping pressure, 1.5 tons/2. Heating time, 15 minutes. Cooling time, 30 minutes. After completion of heating cycle, mold was cooled by circulating water. Mold was taken out from the machine, and 2 halves were opened. Calcium carbonate polypropylene composite sheet was obtained. 3 Results and discussion. 3.1 Tensile test. ASTM D3039 tensile testing is used to measure the force required to break a polymer composite specimen and the extent to which the specimen stretches or elongates to that breaking point. The data is often used to specify a material, to design parts to withstand application of force and as a quality control check of materials. Since the physical properties of many materials at temperatures that simulate the intended end-use environment. Properties of polypropylene composite. The most common specimen for ASTM D3039 has a constant rectangular cross-section, 13 mm wide and 165 mm long. Optional tabs can be bonded to the ends of the specimen to prevent gripping damage. 3.2 Flex Ural test. The Flex Ural test was performed by the 3-point bending method according to ASTM D790, and cross-head speed of 1 mm per minute. 4 specimens were tested, and the average was calculated. The specimen was freely supported by a beam, the maximum load was applied in the middle of the specimen, and the Flex Ural modules are calculated from the slope of the initial portion of the load deflection curve. Figure 6. Effect of CaCO3 loading on the Flex Ural properties of calcium carbonate/polypropylene. 3.3 Impact test. Impact strength is ability of material to resist breaking under shock loading or to resist fracture under stress, applied at high speed. Notched sample of 6 3.5.12.7.3.2 mm 3 size was taken for conducting impact test. Notch of 2.5 mm at an angle of 45 degree was prepared to promote the brittle fracture in material. Impact test was conducted by IJERT impact tester, Seast, Italy make, which has capacity of 50 joule. Speed of pendulum was fixed at 3.5 m/s and striker elevation was 150 degrees. For conclusion. In our work, mechanical properties of calcium carbonate/tamarind, the tensile, and Flex Ural and impact properties of the composites as a function of fiber content were analysed. The tensile strength of calcium carbonate/tamarind composite improved by increasing fiber loading up to 6 Wt% and decreased by higher loading. The Flex Ural strength of calcium carbonate/tamarind composite improved by increasing fiber loading up to 6 Wt% and decreased by higher loading. More addition of calcium carbonate decreases the tensile, Flex Ural, compression and increases the impact properties of composites. Impact properties of hybrid calcium carbonate/tamarind are better than coconut sheet and calcium carbonate/polypropylene composites.